So here is question number 11, everyone. A block P of mass 2 kg is kept on a smooth horizontal surface and attached by a light thread to another block of Q of mass 1 kg. Block Q is resting on the ground, pulley is massless and frictionless. A bullet of mass 10 gram is moving horizontally with velocity 100 meter per second as shown in figure. If bullet hits the block P and comes to the rest, then the maximum displacement of block P in right direction will be what? Now, taking this as a system, let us apply the conservation of momentum as momentum of this system will be conserved. So, according to momentum conservation, we have initial momentum, that is the momentum of bullet only, because initially blocks are at rest. So 10 into 10 to the power minus 3 mass into velocity, that is 100, equals, now final momentum. Finally, these two blocks P and Q are moving with same common speed V, and bullet comes at rest. So therefore we can write common speed V, and the total mass of system is P plus Q, that is 3 kg. 2 plus 1, that is 3 kg. So 3 into V. From here we will calculate the common speed V as 1 by 3 meter per second. As the block P moves right, Q will moves upward in this way. They will have same acceleration A. So their velocity V in this direction, its velocity V in this direction, but as it leaves the surface, Q leaves the surface, what will happen? Acceleration will act in this direction, and this acceleration will act as retardation. So let us calculate the retardation also. This P will start with speed V, and ultimately after some times it will stop. Final velocity will be 0. This V act as initial velocity, final velocity becomes 0. Let us calculate the acceleration of the system. For acceleration, we can have T equals 2a, equation number 1 for block P. For block Q, we have mg minus T equals a. Solving equation 1 and 2, we will get the value of acceleration, that is g by 3 meter per second square. This acceleration acts downward, and thus we can say retardation for Q. Now we will have v square equals u square minus 2gx. Now therefore we have got initial velocity 1 by 3, final velocity 0, retardation g by 3. Now we can apply the third equation of kinematics, that is v square equals u square minus 2ax. V is 0, therefore u square equals 2 into a into x. U 1 by 3 square, that is 1 by 3 into 3 equals 2. Acceleration g by 3 into x. After solving, we will get the value of x, that is x equals 5 by 3 centimeter. So we can say that this block P will move 5 by 3 centimeter in right direction. Option number 2 is absolutely correct. We will go with this second option. Now move on to the next, that is 12 number. So here is question number 12, everyone. A body of mass m is projected upward with ground with velocity v equals under root 2 gh. If maximum height reached by the particle is 3h by 4, then the work done by air resistance in upward journey will be what? We know very well, work done by any drag force, whether it is friction or air resistance, work done by any non-conservative force or air resistance is given as change in mechanical energy. Change in mechanical energy, we can write final mechanical energy minus initial mechanical energy. Final mechanical energy, object has reached at the highest point, velocity will be 0, kinetic energy will be 0. Potential energy mg, height is 3h by 4, minus object is on ground, will take potential as 0, kinetic will be half mv square, half mv square, that is 2gh, plus potential, ground as reference, potential will be 0. Solving it gets us minus of mgh divided by 4. So this is work done by air resistance. This negative sign shows loss. So therefore option number 2 is correct, and we will go with option number 2 only. Now move on to the next, that is 13 number. So here is question number 13, everyone. A man of mass m is standing on a plank of mass 2m and length L0, which is placed on a smooth horizontal surface as shown in figure. If the man walks a distance L0 by 2 on the plank, then the distance travelled by the man with respect to the ground will be what? First of all, suppose the center of mass of this system lies somewhere here. Now initially center of mass is at rest, no external force is acting, so the center of mass will remain at its point. Center of mass will be fixed. Since F external is 0, therefore center of mass will be fixed. Now the person is going right. In order to fix the center of mass, the plank will move in left direction. Suppose the displacement of plank is x with respect to the ground, then according to question, the displacement of man with respect to plank SMP is given as L0 by 2 in right direction I cap. Displacement of plank with respect to ground, we have taken x. Now plank is moving left, so minus x I cap. Now we can write from here the displacement of man with respect to plane will be what? The displacement of man with respect to ground minus displacement of plank with respect to ground. Putting the values, we will see SMP L0 by 2 I cap equals SMG minus SPG, that is minus XI cap. Now from here we will get the displacement of man with respect to ground, which comes L0 by 2 minus XI cap. This is we have to calculate in the question. This is what we need to find first of all. Now let's talk about other things. The displacement of center of mass can be written as m1 into displacement of particle number 1 with respect to ground, that is SMG, plus m2 into displacement of particle number 2 with respect to ground, SPG, divided by m1 plus m2. Putting the values, particle is not displacing, it is at its place, so CM will be 0, displacement of center of mass will be 0, equals m1 is m, SMG is L0 by 2 minus x, plus m2 is 2m, and it is moving left, so therefore minus x, whole divided by total mass, that is 3m. After solving this, what we will get? We will get L0 by 2 minus 3x equals 0. Therefore x will be what? L0 by 6, and therefore the displacement of man with respect to ground will be what? L0 by 2 minus L0 by 6 I cap, that is L0 by 3 I cap. If you talk about magnitude only, we'll get L0 by 3. So option number 4 is absolutely correct. We will go with this fourth option. Now move on to the next, that is 14 number. So here is question number 14, everyone. A system of uniform rod of length r and mass m and a uniform disc of radius 3r by 4 and mass m are shown in figure. The radius of gyration of the system about an axis passing through end A of the rod at perpendicular to the plane of the disc will be what? Now about the radius of gyration, we know very well that the radius of gyration given by k is related with moment of inertia as moment of inertia about A of the system will be what? mk square, where m is the total mass of system, which is actually m plus m 2m. So from here we can get the radius of gyration, that is IA upon 2m under root. So in order to calculate the radius of gyration, we have to calculate the moment of inertia first. Moment of inertia of the system about A will be given as moment of inertia of this rod about A plus moment of inertia of this disc about A. The disc moment of inertia about A will be calculated by the famous parallel axis theorem. The expression will be mr square by 3 for the rod plus for the disc mr, that is 3r by 4 whole square by 2 plus m into 5r by 4 whole square. This portion is for rod and this portion is for disc. Parallel axis theorem we have applied. Solving its IA, we will get m into 209 upon 96 times r square. Now we can calculate the value of k. K equals under root IA, that is m 209 r square upon 96 divided by 2m. mm cancel out. We will get under root 209 upon 192. R goes outside the square root. So this will be the radius of gyration. Looking at the options, we can say that option number 1 is perfectly matching. So we will go with option number 1 only. Now move on to the next, that is 15 number. So here is question number 15, everyone. A uniform disc with light thread bound at r by 2 of mass m and radius r is allowed to pure roll on a smooth inclined plane of inclination 37 degree as shown in figure. The acceleration of center of mass of the disc will be what? We have to calculate acceleration first of all. Now this tension in the string will provide the necessary torque to roll. So writing the torque equation, total torque, that is tension into distance from the center tr by 2 will be what? I alpha. Tr by 2 will be what? I. Moment of inertia of disc about center of mass mr square by 2 into alpha, acceleration divided by r. From here we will get the value of tension, that is ma, where a is acceleration of center of mass, equation number 1. Writing down the translational Newton's law of motion equation, we will get mg sine theta down the plane minus tension up the plane equals ma. From here we will get the value of acceleration. This is equation number 2. Combining 1 and 2, what we are going to get? Mg sine theta minus ma equals ma. M cancel out. The value of acceleration we will get g sine theta divided by 2. G known to us, theta 37 degree. Solving it, we will have the value of acceleration as 3 meter per second square. So option number 4 is absolutely correct. We will go with option number 4. Now move on to the next, that is 16 number.